Hello, and welcome to Structural Analysis MCAD. This video demonstrates the use of the beam on elastic foundation sheet. Some features include all geometry is input on page 2, and there is an input for slot width. Right now it's set to 0. There is input for cracked moment of inertia factor. It's in the red box, and this value is computed below and then must be pasted into the blue box. There are options for singly and doubly reinforced beams if it's a concrete beam. If it's a steel beam or other type of beam, then it's not germane and can be neglected. In this case, it's set at 2. The beam length is set on again on this page. The load point distances are entered from the left end. Do not use distances greater than the beam length or you'll get an incorrect solution. The modulus of subgrade reaction is input, and this should be based on the site-specific soil report. Outside the margin, there is a discussion to help select a correct subgrade modulus that may be used as a guide, but the user is responsible to specify the correct value based on site-specific information. Loads may be input either positive or negative. Positive values are down, negative values are up. If it's a buried beam, you may have either positive or negative values. If it's a beam on the surface, then only positive values are appropriate. The value of beta is computed for use for calculating the value beta L. If beta L is greater than 6, then table 8 is appropriate, which is from Roark's formulas for stress and strain. And if not, then table 7 is required if beta L is less than 6. In this case, with the length that we've chosen of 24 feet, and the current modulus of elasticity and the current moment of inertia, the beta L is greater than 6, so this solution is valid. In this case, we have inputs for yield strength and for the steel modulus. Note if beta A is greater than 3, use case 10. May be appropriate. This condition is for semi-infinite beams. For semi-finite beams with approximately symmetric loading, simply check beta A from the opposite end. Below shows the side view of the beam with loads. Note that the loads scale according to the load. If we were to change one of the loads to a large value, say 7,000, then the plot will update, and you can see this is the 7,000 value. The results start on this page, which is page 3, and we get a shear diagram, a moment diagram, a slope diagram, and a deflection diagram. For design of the, if it's a reinforced concrete beam, then you'll have a minimum shear, a maximum shear, and so on for moment, deflection, and for bearing stress. So all these values need to be checked based on site-specific values for bearing stress. In this case, if you say had an allowable bearing stress of 1,000 psf, then this design would be valid. Next, there are load factors applied to the moments and shears. Load factor for moment, load factor for shear, and strength reduction factors, the bar size is input, number of bars, cover depth, number of top bars, number of bottom bars, and finally required depth, the supplied depth, number of bars, the required moment, the supplied moment. If the moment it checks OK, and in this case the shear checks OK, so we would in this case use 2 layers of 2 1/2 inch bars on the bottom and 2 1/2 inch bars on the top. The cracked moment of inertia is computed here, and again this is the value computed here, which then is input on page 1. It has to be done this way for the because you don't know what the moment of inertia is until you try the reinforcing. Thank you for watching this video, and please contact us at info@structuralanalysismcad.com for specific questions.